Okay, we are going to be looking at how to find the domain of a function when we have a quadratic under a radical. Okay, so as an example, if I had something like f of x equals the square root of the quantity x squared minus 8x plus 15. Okay, so we already know that the value under a radical cannot be negative, right? It could be 0 or greater than 0. So we start out by writing that. We have x squared minus 8x plus 15 has to be greater than or equal to 0. Okay, when we see a quadratic like that, we know that we need to factor it. So we factor. We have the quantity x minus 3 times the quantity x minus 5 has to be greater than or equal to 0. Now, it would be really tempting to say, oh, well, that means that x minus 3 has to be greater than 0 and x minus 5 has to be greater than 0, but that's not the case. When we're multiplying two numbers together, in order to get a value that's positive, we can either have a positive times a positive, right, that'll give us a positive value, or we can have a negative times a negative, and that will give us a positive value. What will not work is if one of those is positive and one of those terms is negative, because a positive times a negative would give us a negative number. Okay? So the one way we can determine that is we can use something called a sign chart. So what we do is we can draw a line, okay, and we list the factors above. So we have our two factors, x minus 5 and x minus 3. What we're going to do is we're going to think about, well, x minus 5, when is that equal to 0? Well, x minus 5 is equal to 0 when x is 5. Okay, so I'm just going to mark a 5 on my number line, and I'm going to put a 0 there. Okay. Now, if I choose to find a number that's larger than 5, if I choose a number that's larger than 5, like let's say 6 or 7, and I plug in that term, I'll end up with a positive number, because 6 minus 5 is a positive 1, 7 minus 5 is a positive 2, and so on. So any number that's larger than 5 that I put into that expression will give me a positive number. If I choose a number less than 5, let's say 0 for example, well, 0 minus 5 would be a negative 5. Any number less than 5 that I choose to input would give me a negative number. So I'm just going to mark that as negative. Okay, now let's go up to the next one. Okay, so we have x minus 3. We're going to start by thinking, well, when would that be 0? X minus 3 would be 0 when x is positive 3. So I'm just going to mark that down here, and I'm going to say x minus 3 is 0 when x is 3. If I choose a number larger than 3, like 4, 5, 6, and I input that for x, I would end up with a positive number. Because any number larger than 3, if I subtract 3 from it, I will get a positive number out. Okay, so for example, if I put in 4, right, 4 minus 3 would be a positive 1. If I choose a number less than 3, let's say I choose 0, okay, so 0 minus 3 would be negative, so anything to the left here is negative. Okay, so I don't actually care about what the values are, I just want to know when it changes from positive to negative. Okay, for the top term, so x minus 3, that's going to make the change when x is 3. If I input a number less than 3, it's negative, input a number larger than 3, it's positive, and then with x minus 5, if I put in 5, I get a 0 out, but if I put in a number less than 5, I will get a negative number greater than 5, I will get a positive number. Okay, now what this tells us is that if I break this up here, right, in the first section, I would have two negative values. So I would have a negative times a negative, that will give me a positive number out. Okay, in the middle, I have a positive times a negative, that will give me a negative number, and then a positive times a positive will give me a positive number. Okay, so that's important because now we've analyzed what sort of number we'll get out. Okay, we are looking for when this value is going to be greater than or equal to 0. So we were looking for positive numbers, right? Or it could equal 0. So we're going to say anything from negative infinity up to 3, including 3, or from 5 to positive infinity will give us a positive value out. Okay, if we choose a number between 3 and 5, one of the terms will be positive, one would be negative. When I multiply a positive number times a negative number, I will get out a negative number, so that would not work. Okay, so that is the domain of our function. Okay, let's flip this over and look at the back side. Okay, now we are just going to be looking for the domain of these functions. So we're going to start off the same way. I know that, let's see, f of x equals root x squared minus 25. So I know that x squared, let's fix that, x squared minus 25 has to be greater than or equal to 0. Okay, so again, I'm going to start out by factoring. I have x plus 5 times x minus 5 has to be greater than or equal to 0. Okay, I want to know when are those terms either both negative or both positive. So I can figure that out by making a sign chart. Okay, so I'm going to list my terms on the left-hand side. So that's x plus 5, x minus 5. Okay, well, x plus 5 is 0 when x is negative 5. If I choose a number larger than negative 5 to input for x, I get out a positive number. If I choose a number less than negative 5 to input, I get out a negative number. Okay, now x minus 5. That's 0 when x is 5. If I choose a number larger than 5 to input, I get out a positive number. Okay, so for example, 6 minus 5 is a positive 1. If I choose a number less than 5, let's say 0, I'd get out a negative number. Okay, again, we're just going to go through and analyze this. So a negative times a negative is a positive. A negative times a positive is a negative, and on the end, a positive times a positive is a positive. Since we want to know when this value would be greater than or equal to 0, we're going to choose the plus signs. So we have negative infinity up to negative 5, and also from 5 to infinity. Anything in those intervals will work, so that is the domain of our function. Okay, let's look at the next one. What just happened there? Okay, let's see, there we go. Okay, so now we want to state the domain of f of x equals square root of 2x squared plus 9x plus 7. Okay, so again, all right, we have 2x squared plus 9x plus 7 needs to be greater than or equal to 0. Okay, start out by factoring that. When you factor that, you should end up with 2x plus 7 times the quantity x plus 1. Okay, and that needs to be greater than or equal to 0. Again, we're going to use our sign chart. Okay, so I have 2x plus 7. I have x plus 1. Okay, and I'm going to go through and analyze when those different terms are positive or negative. Okay, so 2x plus 7 is going to be 0 when x is negative 7 halves. If I choose a number larger than negative 7 halves, it is positive. If I choose a number less than negative 7 halves, it will be negative. Okay, x plus 1 is 0 when x is negative 1. If I choose a number larger than negative 1, it will be positive. If I choose a number less than negative 1, it will be negative. Okay, this isn't, typically we end up with our negatives on the left and positive on the right. That is not always the case. Okay, so just as kind of a side note, if I had something like, let's say I had 1 minus x instead, and I had that on my sign chart, okay, 1 minus x would be 0 when x is 1. However, if I put a number larger than 1, like let's say I put 2 in, well, 1 minus 2 would be a negative 1, so I'd have negatives on the right. And then if I chose a number less than 1, like 0, well, that would be positive, so I'd have positives on the left. So you do have to consider each different circumstance. Really the difference is if x is a positive coefficient, it'll end up being positive on the right, negative on the left, and if x had a negative coefficient, it would be flipped. But you do need to go through and just check that out. Okay, anyway, back to our problem. So if I have, let's see, all the way on the left, I have a negative times a negative, that's a positive. In the middle, I have a negative times a positive, that's a negative. And then all the way over on the right, I have a positive times a positive, which is a positive. My domain then is from negative infinity up to negative 7 halves, including, right? And then also negative 1 to positive infinity. All right, so let's try one more. Let's see, just need to move on down here. Okay, so now we want to state the domain of f of x equals square root of 3x squared minus 13x minus 10. Why don't you, in just a moment, not quite yet, push pause, and then you will give this a try. After you think you've tried it, push play again, and then you'll see my work, and you will know whether or not you have it correct. Okay, so push pause now. Okay, did you get that the domain was from negative infinity up to and including negative 2/3, or from 5, including 5, up to infinity? That is what you should have ended up with, okay? If not, I would check your factoring and check your sign charts to make sure that it matches up. Sign charts are a really useful technique that you'll use this year and then also beyond this year. We will be looking at some sign charts in our next section as well. Actually, I guess it's section 1.5 as well. So it's good that you get a little bit of a preview with this. But you will need to use a sign chart just to analyze where the function is positive or negative whenever you have a higher degree polynomial under a radical. So in this case, we're pretty much going to be sticking to quadratics, but if you see a quadratic under a radical, you need to do a sign chart because that is the only way to know when it would be positive.